It just depends on if you took Banabe or not.
I swear to you, you will not say.
Last time I'm also in French 4.
Yes, but if you took Banabe, you wouldn't be. Hey, Alyssa, cute babysit 4:30 on Saturday, Sunday. Okay. Sweet. All right, so I'm sorry about that. So what's on your test? Review for your test, because you got a really fun test coming up. 3.1 is the chain rule. And basically everything in this class that we take the derivative of is the chain rule from here on out.
I think Bliss wanted to talk to you.
Oh, what's up? Do you want to talk to me or her?
Ashton, sorry.
That's fine. That's fine with me.
That's online.
That's fine. Unless they're making drama when there is none. Okay, 3.1 is the chain rule. Now, the key thing you have to remember about the chain rule is it comes in. What's that?
I just had lunch detention and I haven't talked to anyone in like 8 hours and I hate myself.
What'd you get lunch detention for?
Wait for weather. Talk to the whole class.
What'd you do?
Okay, so if you have 3 tardies, you get a lunch detention. And so he gave me like 8 lunch detentions. I need to make them up, so I'm starting now so I don't have to do it at the end of the semester. And I like ate my lunch in there and I feel like such a loser. And then.
So wait a minute. So listen, hold on. So listen, you obviously learned your lesson because now you're going to be late to what?
Every class.
Yeah, and so now you're coming up here so you can be late to another class so you can talk to Ashton.
It's psychology. I can't sit in there any longer.
Listen, read it out there. I don't think the punishment is working. I don't think it's working. All right, and enough. Luke, eyes up here, eyes up here, eyes up here. Matt, eyes up here, eyes up here. And Alyssa, go away. Chain rule. Don't forget, that comes in a lot of forms. Cosine, natural log, e to something. Power, and guys, enough. That was okay for a while. It's not anymore. To some power, some really nasty thing where you've got like f of x over g of x to some nastier power. Thank you. But the chain rule comes in a lot of forms. The AB kids just finished that. The AB kids noticed that, like, okay, well, basically every problem from here on out is a chain rule problem. Yeah, it is. And second off, that a lot of the problems we've been doing have just been dancing around it. Yes, they have. He's not even here today. Okay, so the chain rule has a lot of different problems in it. 3.2 is implicit. This is what I need to talk a little bit more. Remember, we use implicit when we have either a non-function or something that cannot be written in y equals. So it's either a non-function, like some inputs will give more than one output, or it cannot, boy, I did a stud job of spacing there, cannot be expressed as y equals. And a lot of equations can't. So how do we find the derivative? We have to use implicit. Now, it's still a function. Every input gives one output, but we just can't write it as y equals, which is bad news then because it's hard to put in our calculator, especially if you don't have a supercalculator. Basically, the bulk of the test is those two sections. And they are largely mechanical. Chapter 4 is not. Chapter 4, then we are taking the derivative set equal to 0, solve for x. Intervals of increasing and decreasing. Solving related rates problems. Okay, 3.3. 3.2 then is log derivatives. 3.3 is log derivatives. That involves like the natural log of some function, 2 to some power, e to some power. Don't forget, there is a proof that you have to be able to reconstruct in that one. That is y is equal to x to the x power. I'm telling you, it is a 4-point problem on there. You will have to prove the derivative of x to the x power. So I'm telling you, that is on there. If you don't know that, I can't make it any easier besides like handing you the answer key to that one. And we did that one in class.
Not take your.
Good news, it's on the internet. Caleb.
Yeah, actually, I was going to say, Paul's on my math notes if you need that stuff. Any of this.
All right, what else was in that section? To the power. Oh, log base a of u of some function. 3.4 was sine.
Wasn't the inverse of 3.3?
I think logs came first.
Logs came first.
But we skipped 3.
No, it didn't.
Hold on. Let's fact check the facts here. Let's not be inaccurate. I don't want you to go home and be like, Beckman said it was in the wrong section. Go fire him. Let's look it up. There's a right answer. There are facts in the universe. Let's make sure we put facts. Hold on. 3.3. Ah, that was 3.4, 3.3. Oh, now your notes are all messed up. Hashtag whiteout. That's why Mrs. Kumar always kept it on hand, because I made mistakes and she never did. 3.3, sine inverse, cosine inverse, tangent inverse. Don't forget you have to do that with a chain rule problem in the middle. 3.5, I skipped. 3.6 was hyperbolic. So you have to know the derivative of sine, hyperbolic, cosine, hyperbolic, tangent, hyperbolic, and of some function. As always, there are beautiful optional, these are totally optional review problems on page 273 for regular problems and 276 for AP problems. The AP ones are definitely something to look through because that's usually where I go for problems. Caleb.
Derivative of inverse functions. I'm not just general inverse functions.
I do not recall putting a question about that on there because I think I know where that question's coming. Okay, just so you know, so we'll finish this. We'll take that test on Tuesday. We'll finish chapter 4. That's the end of derivatives before Thanksgiving. We'll at least get through chapter 5, the integral, before Christmas. Now remember, the school goes really fast in November, December. There's 3 weeks in November, 3 weeks in December. So then we have 1, 2, 3, 4 chapters to finish for the class. So we will get through chapter 9 in this class. We don't even have to do all of chapter 9. We only got to do part of chapter 9.
So we have 5 more chapter tests technically.
You have 3, 4, 5, 6, 7, 8, 9. So you have 7 more this year. At least 1, 2, 3 of them are this semester. So 1, 2, 3, 4 next semester. Now, what's that? You will have something on the day of the final. It just depends on where we are. If it's a chapter test, it's a chapter test. If it's a final, it's a final. We'll see where it is. Stall?
What?
And Luke, ways to make your class hate you in March.
I didn't say
Stall
anything.
through this class, because when we have to cover finite series and sequences in more than one day, and then you got to watch an hour-and-a-half video when you got home. So those of you who had the flip, it would be the flip, except we do class during class and at home. That's where that's where the people who stall class become not your friends. So, and what? Amundsen?
And home.
Oh yeah, and you'd have to do 2 sections of homework every day too.
Are we going to take a mock taking exam?
We will if time allows. My first preference is always to make sure we finish the class and that we have an adequate amount of time to go through. Luke, I take that back. I am dividing up the series and sequences because there's 10 sections in that chapter, but I am dividing that into 2 tests because there's 3 tests that really matter and then a whole bunch of details. So we're going to take the 3 that matter and then the whole bunch of details because that chapter can get full of too many details if we take it all in one. And I've done that in past years, but I'm breaking it up this year. Yep, Caleb.
Question about infinite series. So we start with sequences and then we go to the series.
Sequences for like a day.
Oh, okay.
All right, let's take a look at a problem though. Let's go for 2xy.
We won't have to know inverse hyperbolic, correct?
No. You don't even need to know that for the AP test. That's fun life knowledge, things that, if you're in a dark alley, you might need to know. But when I teach ABC next year, when we have like everyday class first semester, yeah, I'll cover stuff like that, but we only have it every day. Okay, 2xy plus, what should we go for? Plus x squared is equal to 7. And here's what we got to find. We got to find dy dx in terms of xy. And then we got to do what I haven't done with you yet. We got to find the second derivative in terms of xy.
Wait, if you say dy dx, why do you have to say it in terms of x?
Which is, hold on, let me go back to that question. It's a really fancy way of saying solve for what? Dy dx, right? So in other words, they want dy dx on one side and everything else on the other. For AP, the real reason they do this is it makes it tolerable to grade. If you don't do that, then there are hundreds of different correct answers you have to, but there's only 2 correct answers you have to check if you make kids put it in terms of x and y. So really that's just like grading practicality. But virtually all of the actual AP problems have you do that, because on the multiple choice section, they got to have a way for you to verify your answers correct. And on the free response, it just makes it quicker to grade. The harder part is the second derivative, just because of what we have to do to find it. Okay, and I'm going to talk about some strategies you can use on this one. There's different ways you can work through this problem and get the answer. I don't really care which one you do, just which one works better for you. Ashton asked the question that I always ask first, which is, what rules are we going to have to use on this one? We are going to have to use the product, chain, implicit. One more. No.
No, not that one.
Because that's part of the chain. Remember, the power rule now is kind of gone. And it's just part of the chain rule. There is, yeah, but that's still a like, it's just what's the derivative of the chain? One, right? There's one more rule. Remember, I told you people can do a very hard problem and get it totally wrong because they forget what? Constant, right? What's the derivative of 7? 0. Just so you know, AB took a quiz today, and just looking through it briefly in between classes. Great job taking the derivative of the left-hand side. Totally got the right-hand side wrong because you're used to stuff being hard, so you don't think it's going to be equal to 0. Okay, so let's take the derivative first because we got to do that. So let's go do that. The derivative of this is going to be a product, so I'm going to let this be F. I'm going to let this be G. F, G. So the derivative of the first is 2 times the second plus the derivative of the second times the first. What's the derivative of x squared? 2x. What's the derivative of 7? 0, right. So, okay, that's the end of calculus, though, for this problem. That's the end of calculus, so now we're just on to our friend algebra. Stop and check out questions so far. Worked this exact same problem last year because it was in their book last year. What's the first thing I can do to make this easier?
Get the one.
Yeah, let's make it easy first. Notice all the terms have a 1 in it. 2, so we can divide everything by 2. Don't make life hard when we make life easy. Everything's got a 2. Let's divide both sides by 2 first. Look at that. Y plus now we've got x dy dx plus x is equal to 0. Look at that. We just made our life simpler. Made our life simpler. It's like dumping the boy who asked you to homecoming but won't give you a calculator. Just made your life simpler. You only got to worry about you now. Divided everything by 2. All right, now I want to get, somebody said this, but I want to get dy dx by itself. Do I want to move it to the left, or do I want to move dy dx to the right, or move everything else to the left?
Everything else.
Okay, so then we minus y, minus x, minus y, minus x. Now, before you start rioting, is there any, like, is one of these significantly easier than the other? Not really, no. So it doesn't really matter which side it is. And that's why I said to Ayana's question, there's going to be 2 answers to this. One that they moved everything to the right, and one that they moved everything to the left. The only difference is multiplying the top and the bottom by negative. Okay, so I got x dy dx is equal to negative x minus y. Last step, let's call on victims here. Mr. Wells, what should I do to solve that puppy for dy dx? Divide by x, divide by x. Man, can I separate those 2 fractions and have -1 or -1 minus y over x? Yeah, is that prettier? I don't know. Fielder's choice there. It's an arbitrary choice. Let's stop and check out the questions from you all. Questions from you all. Everybody totally can do that. Okay, so that's your answers in terms of x and y. Okay, before we go on, any questions? Everybody's got it? Now, let's think of finding the derivative. Would it be easier to break it up to take the derivative of this?
Yes.
Yeah, I don't know. Maybe, maybe not. That's your choice. Let's call on a victim. Who has it? Josh, you're looking very interested. Should we break those fractions up? Should we break this couple up or keep them together? Josh, boys and girls are like, break up. Yeah, make Josh available for me. Josh, what do you want to do?
Everyone's saying break it up.
Okay, let's break it up. Fine. Let's go all homecoming on this. Day after homecoming.
He said keep it.
No, he didn't.
Josh, which one did you say?
Keep it together.
Okay.
That's right. Go get the status quo.
All right, now what rules are going to be then? Question. No, it would have been a question rule either way, so don't get mad at Josh for that. On my top then is f of x is equal to negative x minus y. My g of x is equal to x. Now, I keep saying this. Do you have to write this stuff over here? No. And Mrs. Kumar, Mrs. Ringhammer would have told you the same thing last year. You don't have to write it. It's just a way of helping you organize information. Like when you factor, some teachers teach this little circle method thing. That's not factoring. That's just a way of organizing the information in factoring. You don't have to do this. I don't do this. If you want to, you're more than welcome to as a step to help you, but you don't need to do that step. What's the derivative of this, though? Okay, what's the derivative of minus x?
-1.
What's the derivative of minus y? Minus dy dx. What's the derivative of this? Say it again. 1, right? Okay, so what's the quotient rule? It says, well, first off, we have the d squared y over dx squared. Second derivative over x's change squared. That's equal to the bottom squared. So let's put that in there first, x squared. The top, the derivative, oh, whoa. Yep, okay. The derivative of the top times the bottom. So we take the derivative of the top. Derivative of the top multiplied by the bottom minus the derivative of the bottom, which is 1, multiplied by the top. Okay. Stop and check out. We're going to probably clean this up just a little bit here. Before we do that, any questions on that? Okay. Play a little game with you. How many think this is right? This is my final answer. Good to go. Put it in the box. Move on. What do I got to do? Okay. Not simplified. Hold on. Okay. I could simplify it. What? That's optional. If it's free response, I don't want to simplify this because I might get the answer wrong. What do I want to do though? Shottery.
You want to plug in dy dx.
Say that again.
Plug in what you got for dy dx.
Right. Because the answer needs to be in terms of just x and y, not dy dx, just x and y. So they want the second derivative to only be dependent on the position. They do not want it dependent on the position and the rate of change at that position. They just want a relationship in terms of the position. So what are you going to do? You're going to take this, you're going to plug it in for that. And that's where Josh said keep it together. Maybe some of you that did this last year, I'm not even sure if you do this in the IB class. Maybe some of you that did this last year realized we were going to have to plug this back in. Did you do implicit in IB? Never heard it before? Really? Oh, look at the suffering you missed out on. Like, look at the human suffering that could have been but wasn't. Okay, so let's plug it in. What's that?
Thank you for giving us this experience.
You're welcome. I feel like, Willow, you've had me long enough to know that I am a big fan of making sure you suffer as you should.
Oh, my dad would be very much approving of that philosophy. So.
Well, I don't know what to say to that, but I don't feel like I know your dad well enough to answer that question. So, all right. I don't know why I put another parenthesis there. That was bad. Okay. Now, can I clean this up? There's where I needed the other parenthesis. It was right there. That's why I was writing it. Okay, let's stop and check out questions. Now, there's a concept here. I got to get it in terms of x and y. There's algebra that I could clean up on this puppy. Kind of thinking down the road to this, at some point I might have to set it equal to 0 and solve for x and y. That's where I have to clean it up, and that's why I'm willing to be tolerant of where you simplify at this point. Questions on that?
It simplifies really nicely.
Yeah, it does. Oh, yeah, it works. Yes. It works out beautiful. But let's be honest, Caleb. What calculus problem doesn't? Even if the answer's like ugly, when you show it to like your parents, like, Mom, here's why I don't have time to clean. Right here. Back man. 4-letter first word, 3-letter last word. Back man. Right.
The question you gave us on the notes for implicit, that did not simplify.
Yeah, that was ugly. That was like Caleb Neal.
4 lines of just terms.
Yes.
And I didn't spend.
It was ugly like Caleb Neal.
No. Caleb Neal loved that problem.
I was like, that's a little.
Oh my goodness! Notice how it's never girls that burst out like that in class ever. Like, you ever wonder why I say don't be that guy?
The population, like the odds are, it's gonna be guy.
No, I hate to break this to you. There are more of you than there are more girls in the world than there are boys.
Not in this
Class,
class.
Mr. Beckman.
Oh, okay. That's true.
No, you're
Only for the actually, hold on. Yeah, there are.
Yep.
Yep. It is, which is why you boys should be very good. It's much harder for you to get a date in this class than it is for the girls in this class to get a date. They basically have 8 choices for every one you have. So the whole school. Ash, some of you are going to mines next year, Sean. It'll be worse there. So distribute that out. Oh yeah, there's lots of guys at mines.
Wait. TX guys.
Thank you. All right, distribute that x out. That gives you a negative x. Distribute that x there. Look what cancels. Boom, boom, and then look at this. You get a negative, so that gives you a plus x and a plus y. I know. Look how pretty that is. Distribute this negative. That gives you a positive x and a positive y. Look what cancels. Goodbye, goodbye. So what are you left with? You're left with 2y plus x. I don't know why I wrote the y first. Look at that pretty second derivative. Yes, the first derivative is train wreck, but the second derivative, like, it's just beautiful. Beautiful. Sean, stop touching him. Other questions on that? Caleb first, then Ashton.
That's a rally.
Hold on.
What level of simplification do you want next?
I always ask myself, is going further going to make it either prettier or I have a reason to? In this one, it just turns out that it makes it really pretty if you do. Or like I have to solve it, then I have a reason to. Like remember at the start of the year, some of you had like problems that had like 3x plus 1 in the denominator cubed, and you've like foiled it out. And I'm like, oh, don't do that. Like just use the generalized power rule. Use the generalized power rule. You only do stuff in this class when you have a reason to. And those reasons are I have to solve something or it makes it look better. This one clearly looks better if you simplify it. So they would make you simplify it. If it does not, they will not make you simplify it. This is not an algebra test. It is a calculus test. Ashton. Can you say it again? We'll see. I know this one does. I don't think this one does implicit. But let's take a peek. I always like exploring the calculator. So let's go to menu, and what class are we in? Okay, let's see. Can it do implicit? Yeah, it can. Oh, look at that. Implicit differentiation. Oh, so let's, I know what we have to do on this. Okay, so take out your super calculator real quick. You may say I don't have one. Well, good news. Basically, all the holidays of the world are coming up. Kwanzaa, Hanukkah, Thanksgiving, Veterans Day, Christmas, New Year's. There's a holiday that I guarantee almost every family celebrates that you could say, Mom, I don't need like bling this year. I need a calculator this year. And then your parents just be like, my daughter turned into a nerd. This is all Beckman's fault. Okay, go to menu, go down to calculus, go down to, and what's wrong with getting your daughter a Veterans Day calculator? Like, that just feels really American right now.
Yeah.
All right, let's type in the original problem. Ashton, what was the original? Hold on a sec. Ashton, what was the original problem? Can you say it again? Ashton, a lot of boys apparently like responding to your name in this class. Can you say it again?
2x squared.
X squared. Is there an easy squared button? Yep. Is equal to 7. Where's the equal sign?
Just above the power thing.
It's above the power. Oh, yep, there it is. It's equal to 7. Now, I assume I got to tell it something here. So I'm going to assume I got to tell it x comma y.
Yeah.
Now here, just so you know, Mohit basically hangs out in my classroom all day. But today, he was working on Calc 3 homework that had implicit differentiation with x, y, z, and t. So you do have to tell it what your input variable is. So you got to say, basically, when you put x comma y, dy over dx. Now, if it's three-dimensional, it could be dt over dx or dy over dt. But that's where you're saying. Let's see if it can find it out. Oh, it says undefined. That's bad news, Bears.
It's because x, y is its own variable. You have to put a multiplication sign inside.
Oh, duh. I'm sorry. Boy, if you had a better teacher. How do I bring up the previous lines?
Hit down arrow twice.
That's right.
It's beautiful.
Holy crap.
Actually, do you think I was like playing you when I told you that this was? Now, here's the other deal. Can it find the second derivative?
It gives a different answer.
Oh, let's see what it gives. Let's go forward. Did I make a mistake? Hold on, before we verify the calculator, let's make sure I'm right. That is the correct answer for the first derivative, yes. So I take the derivative of the top times the bottom times the derivative of the bottom times the top, where the bottom squared. I distributed that to get negative x. I distribute that. That cancels that. Yes, 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 yes. I feel reasonably confident in my answer. Does anybody find a mistake? Okay, let's plug it in. So now I'm going, okay, question. How do I make it do the second derivative? Yeah, you just do the derivative again. It doesn't have a second derivative button for implicit. You just take the derivative of the derivative, and that gives you a second derivative. So menu, calculator. Oh, by the way, I did see some of these getting a lot cheaper on eBay, too. I saw one of these for $85. Now, it looked like somebody had just taken a CAS and uploaded the CX software on it. So that might be some illegal Russian modification of the calculator, but it's cheaper.
It's
Pick your
also
poison.
illegal.
Well,
Nobody cares.
well, I have a student in the other AB or in my purple AB class who has attempted to upload the software from the CX onto it, and so far so good. So,
Are we your only BC class?
yeah, you're the only BC section. How do I copy this down in here?
Control
You can
negative
hit enter
sign.
there and it's fine.
Control
Yeah,
negative
just
sign.
say yes.
Oh yeah, just hit the answer. Control negative sign. Thank you. Comma x comma y. No, do I have to set it equal to something?
Yeah.
What do I have to set it equal to?
I think you can. I tried setting it equal to dy over dx.
Did that work?
It gave a different answer.
Wait, why do you have to set it equal to something?
Because this is equal to something.
Can we
What's
set it equal to 0?
oh, let's just set it equal to y. Let's see if that does it.
Why?
Set it equal to y.
That was not the answer. we wanted.
That's not the answer we got. What do I got to set it equal to? Because that's going to be the hard part. I got to tell what it's equal to on the other side.
Because it doesn't know that this is equal to dy dx.
Yeah, it doesn't.
Plug it
So
back in.
I set it equal
how do I get
to
around
dy
that?
dx, but I actually typed in dy dx is what it's equal
did it work?
to.
It gave you a different
y
answer.
over x.
Yeah, all right. Anybody else?
Try 0.
Okay, we'll try it. Why not?
Why?
Say it. Did anybody get it to give the right answer yet? Let's Google this.
Zero doesn't look either.
I feel that on.
Zero and one both got the same answer.
Does not have that functionality at this time. Sorry. You have to do the second derivative by hand. Sorry. I know. Hashtag refund. Take it back. Send it back to Amazon. Tell them it doesn't find the second derivative implicitly. It's probably the only place you can take it that the person doing your return would get it. Well, but then the problem is that now you're letting y equal another, and there's a y on the other side. Remember how last year some of you got really mad at me because your AP Calc, remember you took that practice exam and like your scores were tanked because you were doing some notational things that weren't correct? That is one of the reasons why. Because if I set this equal to y, there's a y on the other side that then it assumes they represent the same thing. But I want one to be the derivative and one to be something else.
When you took the first derivative, did you have to set it equal to?
I just typed in the original equation because it was equal to 7.
When it gives you y over x, you plug in dy dx for y, that gives you the correct answer then.
What did you type in?
Never mind. I didn't do that.
Why can't you just do 2y plus x equal to 0?
Because it's not equal to 0. It's equal to the
If you
derivative.
multiply.
Just give you the answer.
That doesn't make sense. Ignore what I'm saying.
That's okay. Ashton, can you say it again?
Just give you the right answer without inserting the dy dx.
No, because you have a y on the other. So what you would have to go back and solve the original problem for y and substitute that in, but then it's not even an implicit problem anymore. Because that's what this MIT site says. You have to solve the original equation for y, which then if you solve this for y, why would we even mess around with implicit differentiation? Now, that's not the prettiest thing normally on a hard like XY problem to solve it for y. So they're saying it's just the function's unavailable at this time. Basically, there's just not a, well, some of you guys that like to look on there and see, is there a dy dx button on like one of the menus?
Or you could type
Well,
it
you
in there.
put it in.
Yeah, but it's not giving me the right answer when I do that. I'm a total nerd. Why am I talking about this for so long? Okay, questions on that? I need therapy. Okay, okay, that's what's on your test. That's the only thing that I haven't talked about so far. This, now I've mentioned at the start of the year, chapter 1, really hard. Chapter 2, a lot easier. Chapter 3, pretty easy. Chapter 4, pretty hard. Chapter 5, pretty easy. Chapter 6, pretty hard. Calc C, really hard. There's one test that's pretty easy, parametrics and polars, but at that point of the year, the hardest struggle I have is you guys doing homework because you have so many other things going on that are taking your time, which is why I save it for the very end. But this is like one of the last 2 or 3 super easy tests. Anything you want to go through beforehand? I can work problems. I can give you time to catch up on your homework and get it done.
Well, I have
Kiwi.
a question. So
Yes.
for hyperbolic, so we need to do will we ever need to write out for your test the e to the x minus?
No,
plus
that's
minus
just FYI analysis. That's why I was saying sometimes I really like to cover the theory of math, like telling you about alternate geometries, but that's not like relevant to what you have to do on the AP test. And I do need to make sure I do my job first, which is getting you ready for the AP test. Like, yes, no, don't shake your head, Stefan. Knowing about alternate geometries is great first date material when you're dating somebody way smarter than you. And you may say, but I'm the smartest person I know. Why on earth would I date somebody smart? Letting you know, my wife's way smarter than me. It's fun to date somebody smarter than you. They challenge you. They make you better. It's boring to go on dates with people that aren't as smart as you because you're like, I can't talk about calculus, differential equations, limits, pre-calc, algebra 2. I don't have any geometry jokes. Yes.
For this test, do we need any definitions?
No. You need to know mechanics. Like you need to know what sine inverse, cosine inverse, tangent, sine hyperbolic, cosine hyperbolic, tangent hyperbolic. You need to know the rules for like e to a power. Yeah, it's just derivative rules, which is why I said you will have to make note cards at the end, like flashcards, to help you review for the AP test. It wouldn't hurt to make them now, but I'm not going to require it. Lexus.
Do we have to know squeeze theorem for the skill quiz?
You do not have to know squeeze theorem for any of the skills. You can use it, but you don't have to. The squeeze theorem is primarily used to find a composite function of a trigonometric identity like this one.
Are we going to see that again?
Wait, were you
Yeah, I
talking
guarantee you, there was an AP question last year on it, and there'll be an
like
AP
in
question
this
this year.
class.
Just as a review, I should answer that fully. In the series and sequence part, there will be squeeze theorem used to show that we know that this summation is between these two, and these both converge, so the one between it has to converge as well. We also use it in the integral for the exact same thing we did with the limit. Like we know that this integral is always between these two. Right. So it's the same. There isn't like a new squeeze theorem. We're just using it for something else. And all the squeeze theorem does is say, this is always between these two. The same spot. Something always in between it has to be going to that same spot as well. Kiwi.
So when is the skill quiz again?
Skill quiz will be after your test if you have time.
Okay.
But you don't worry about that until after that.
Why would we do that after a test?
Will you tell me you never practice and do conditioning and wrestling at the same practice?
But like, you wouldn't condition after a match, is what I'm saying.
Yeah.
You know?
Shottery?
Who said I would?
Shottery, let me tell you about. Let me stop the recording here.
Ooh.